All right, let's go ahead and get started. So again, hello to everyone and welcome to today's webinar presentation titled How to Build an Open Data Lake Analytics Stack, brought to you by Ahana. I would like to introduce you to today's presenter, Dipti Borkar, who is the co-founder and chief product officer at Ahana. Dipti is a co-founder of Ahana with over 15 years experience in distributed data and database technology, including relational, NoSQL, and federated systems. Prior to Ahana, Dipti held VP roles at Alexio, Kinetica, and Couchbase. Earlier in her career, Dipti managed development teams at IBM DB2 Distributed, where she started her career as a database software engineer. Dipti holds an MS in computer science from UC San Diego and an MBA from the Haas School of Business at UC Berkeley. At this time, I'd like to pass it off to Dipti for the presentation.
Thank you so much for the introduction. Hello, everyone. Welcome to today's webinar. We are going to talk about building data lakes, open data lakes specifically. There's a few topics that I want to take you through today. First, we'll talk about how things have changed in the data world. I myself have gone through quite a few transitions, starting off with relational databases and DB2 data warehouse. I was a core storage and indexing developer there. Then I transitioned to NoSQL, and from there to this disaggregated stack where compute and storage are no longer co-located, and has opened up quite a new, an entire new set of technologies to make analytics more flexible, more open, and that's what the session's about. So we'll talk about that. We'll talk about how Presto in particular can help with SQL analytics on top of data lakes. And we'll look at some of the use cases. We'll look at the data lakehouse use case in particular, and we'll see what the components of that use case look like. And then we'll do a quick overview of Ahana, which is a managed service for Presto to make SQL on data lakes easier. So let's get started. So at a high level, data warehouses have been around for a long time. Everyone's familiar probably with Snowflake, Redshift, BigQuery, the cloud data lakes, the cloud data warehouses. The more traditional ones were Teradata and Oracle, DB2 warehouse, etc. And on top of the warehouses, you typically had reporting and dashboarding workloads with Tableau, Looker, other BI tools. This was traditionally a lot of enterprise data, but the world has changed quite a bit, and there's a lot more different types of data being generated, a lot more data. And so what we're seeing is just the amount of data has grown. We're going from gigabytes to terabytes to petabytes. And so the kind of technologies to manage this storage needs to be different, because some of the data warehouses become cost prohibitive as more and more data gets ingested into them. We're also seeing a lot of different types of data from different types of sources. IoT data, streaming data, third-party data. There's more and more sources that are being generated, as well as the speed of data is changing. We were in a world where it was a batch process, or data would be updated on on a daily basis or every few days. And now it's become a lot more real time. There's a lot more fast data. And so streaming data needs to be managed as well. And finally, the third one is users are looking for a lot more flexibility with their data, with both open source as well as open formats, so that they're not locked into the formats that some of the data warehouses have, which are not open, they're not accessible. So with all these changes and a lot of this data moving to the cloud and cloud data stores becoming so popular, then there's a new stack that's emerging. And there's a lot of different workloads that can be run on top of these cloud data lakes. If you think about it, S3, which is the Amazon data lake storage, right? It's ubiquitous, and it's very, very affordable. It's 15 years in the making. There's trillions of objects in there, but even now, a lot of this data is not analyzed, and that's where the data lakes come in. You can have you can have workloads, whether it's more traditional workloads, right, reporting and dashboarding, or new workloads like data science or transformation workloads, all running on top of these new cloud data lakes. So, when we say open data lakes, right, what exactly does that mean? What are the characteristics of open analytics and open data lakes? The first one is open source. So, there was a very popular term said your software is eating the world, right? And what we're seeing increasingly is more and more of these enterprise software areas have open source options. And so there's an open source version for BI tools, for data catalogs, for query engines, and even for storage tiers. And so open source and open stack is something that users and enterprises are looking for, because they've been in the place with traditional data warehouses where they get locked in, and it's very hard to move from one technology and to another. And with open source, you have the ability to contribute back. You're not waiting on a single vendor's roadmap. You have the ability to participate in the community, participate depending on the kind of project, right? Contribute back and actually be part of these innovation cycles. The second characteristics of open analytics is open formats. And specifically for analytics, there's a range of column formats that have emerged as very popular. So data lakes can store any kind of data, right? And so this can be JSON, CSV, text, and so on. But there are some formats which are columnar formats, particularly Apache ORC, for example, or Apache Parquet, for example, that are very, very optimized for analytics. And a lot of different engines and technologies and projects support them. So when you use open analytics and open stack, you're not locked in where you don't have visibility into the storage formats. In fact, you can run multiple different types of processing on these formats. As an example, Spark for ETL or transformation use cases can use ORC or Parquet. Presto for SQL analytics can use ORC or Parquet. TensorFlow from a machine learning perspective recently added support for Parquet as well. And so a lot of different types of processing can be run in one place without moving the data around or ingesting it into different places. So that's open formats, which gives you a lot of flexibility. The next is open interfaces, and interfaces or APIs, if you will. These can mean many different kinds. The most popular ones are, for example, SQL. SQL is widely used, and JDBC, ODBC are, if you will, the drivers that connect with many different tools, technologies. And so these are very open to different projects, different technologies. So you have flexibility as an end user, as a platform team, to widely support a range of different technologies for your end users. And so the open interfaces help a lot. And then finally, open cloud. At today, a lot of users or end customers are on AWS. There's some on GCP, there's some on Azure. But this open stack and technically an open source can run on any cloud. And so this gives you the flexibility to move from one cloud to another or have multi-cloud support. And so this gives users and platform teams a lot more flexibility, a lot more cost effectiveness than the traditional data warehouses. So this is how it's a way to think about open data lake analytics and what are the characteristics you might want to look for as you build your stack. But before going into that, let's take a look at the traditional approaches. Some of the traditional approaches were and that are still largely used, and now there's a cloud version of the data warehouse with Snowflake and others. And these data warehouses tend to be relational databases. They are tightly coupled relational databases where you have compute and storage and everything kind of pre-integrated in. This obviously is great from a performance perspective, and if you want, highly low latency use cases, it is a tightly coupled system. It does better at structured data and as well as better at model data, clean data. So star schemas, Snowflake schemas that are very, very clean, And you typically would, extract, transform, and then load it, ingest data into the warehouse. SQL access tends to be the primary access for it. The challenges that users are seeing with it, and as I've talked to different community users, customers over the years, from 3-person data platform teams to 100-person data platform teams, there's a range of different challenges. Data warehouses is an ingest approach, right? So you are moving your data from your probably increasingly a lake or a cloud store into that warehouse, and it gets expensive over time. It might be difficult to manage depending on which one it is. Cloud data warehouses tend to be much easier than the on-prem versions of it. It becomes costly to maintain because over time, compute and storage together means you're paying double for your storage, perhaps, and the compute costs are also higher. And you have limited versions or limited data types that might be supported, limited access paths that might be supported. For example, machine learning workloads may not be able to run on the data warehouse itself. And so we are seeing this big move from a data warehouse to data lake perspective. There's two strategies that platform teams are using. In some cases, they may augment the warehouse where they say we'll have certain percentage of data in our warehouse and certain percentage of data on all the rest of our data in our data lake. And in some cases, where they may be a pre-warehouse user. So let's say they haven't picked a data warehouse yet, and they're on, you're on a MySQL or a Postgres or an RDS or an Aurora, and you're running Tableau or Looker or Top, and you're looking to modernize and expand your analytical program and get more advanced. Then you would go, some platform teams are choosing to skip the warehouse and move to the data lake. But both approaches, whether you skip the warehouse or you augment the warehouse, are good approaches. Depends on your platform team's skill set, depends on the requirements, and many other things. But there certainly is a big move to this new approach, and there's a few drivers. Digital transformation. Everything is kind of moving into this digital world. A lot more data is being tracked. The second one is real-time events, as I mentioned earlier. A lot more data sources, events, all kind of events, IoT data, behavioral data, telemetry data. We call this fast data, and there's a lot more of that being generated. And this is very expensive to constantly land into a warehouse, and so it lands in a data lake typically. And then the third one is new and different variations and innovations that have come into processing techniques, just data processing techniques. And given that platform teams over time may want to have different types of workloads, they might want to have transformation workloads, SQL workloads, machine learning workloads. It's easier to think about a single platform where all the data is, and you can run all these different workloads on top of that one single system. And so we're seeing this disaggregated stack, as I mentioned earlier, or what I've started to call the deconstructed database, which is the data lake. So the traditional data lakes were the first version or the first iteration of the data lake was the Hadoop ecosystem. So Hadoop was built for kind of an on-prem world, was built for the file system, HDFS. The data was structured, semi-structured. You ingested into the HDFS system, and then there were different workloads, which we are now seeing increasingly, like discovery, data science, as well as data science with notebooks like Jupyter, Python, and so on. And these were slightly less expensive than the more traditional data warehouses on-prem. Good enough performance, as well as supported a good range of data warehouse workloads, and not all of them, but a good range. And so the challenge with the Hadoop ecosystem and these traditional data lakes was the complexity of it. There were many different components. The Hadoop ecosystem has over 70 projects, at least 10 to 15 that you absolutely need to get things going. And it took a long time for people to ingest data in and get value from their data and actually run analytics on it. It would take months or months at a time, 3, 6, 9 months to actually see value from it. And that has changed quite a bit with the move to the cloud, as well as newer technologies, projects that have emerged. So let's take a look at those. So as I was saying earlier, there is a big move to these to the cloud data lakes. We talked about the traditional warehouses, and this is the cloud version of it. And there's different types of technologies, different types of um, projects that have emerged over time to support the lake house and the data lake approach. So on the top, your workloads may not be that different. You might have a reporting and dashboarding workload. You see the usual suspects like Tableau, Looker, ClickSight on AWS, for example. There's many others. Superset is an open source version of it. And then underneath, you would have different types of engines that support these different workloads. For reporting and dashboarding, for the pure SQL workloads, you have Presto. For the data science workloads, depending on the kind of data science, if you're doing SQL data science, with SQL notebooks, then it can be Presto. Or you could do a data frame-based approach with Spark or TensorFlow for a machine learning-based approach. And then for transformation, for in-data lake transformation workloads with Python or Airflow, Spark tends to be used widely and is a good engine of choice for that. And so these are the kind of different workloads that you could run on a single data lake and get value from your data in many different ways. It could be business value from a reporting perspective. It can be a product manager or a data scientist trying to get information for the marketing teams in terms of what's working, or it could be some of it could be governance and management of data itself with the transformation workloads, like with Python and Airflow, where they're trying to clean clean up the data, create derived data, and things like that. All right, so in terms of how all of this fits into your current ecosystem, right? All of these new workloads and these new systems we're talking about, how does this fit into taking one step back into the broader ecosystem? So there are still a range of different data sources, different data management systems. You have your operational data sources. That's where the data is being generated. These tend to be our DBMSs, MySQL, Postgres, Oracle, others. Also NoSQL databases like Mongo or Couchbase and others. And then typically this data historically has been moved using ETL into a data warehouse, where you have both storage and the SQL query processing. And then on the right, you have your consumption, right? So you have your output, which is how you're consuming all of this data, and there's a variation of things that we've talked about. Now, if let's say you have an augment strategy, you have more data that's coming in, streaming data, IoT data, and this is going third-party data, right? This may be used. You might use now an ELT approach, where you load the data first into the lake and then you transform it, and then you have your different processing engines on the top, as we've talked about. So you have Presto. That's where Ahana comes in. Ahana is a managed service for Presto for SQL workloads on data lakes. You have Databricks, which does the machine learning, as well as the transformation workloads that it's very good at. And then there's other workloads like data virtualization or federation, but much smaller in size. Typically, that's what we've seen. So this is how kind of the open data lake stack might fit into your existing architecture, with your operational data sources, your warehouse, your ETL or ELT or streaming engines like Kafka or Informatica, Talent, or whatever you choose. And then you have your other components on the lake side of things. All right, so up until now, we've talked about data lakes, the traditional data warehouses, and how there's this move to the data lake approach and the data lake stack. Let's go into a little bit more details of some of these engines and how they fit in, what the use cases are, and so on. So I touched on a few different types of engines. Specifically for the SQL query engines, there are a few that have been used more recently that have emerged in the market. Spark SQL was built. It's been around for some time. It's a great query engine for transformation workloads. And then Presto, which was created at Facebook, just saw a very kind of dramatic growth over time because of the adoption of these cloud data warehouses, cloud data lakes, where it can run on, and it's seen, it has tremendous momentum. Another one is Apache Drill that came out of MapR. It's based on the Dremel paper. It's a federated engine, and it's kind of flattened out over time. And so there's a couple of different approaches that you can use. For the rest of this presentation, I'm going to focus on Presto. That has emerged as the de facto query engine from a SQL, interactive SQL or data lakes perspective, and we'll jump into that next. So let's talk a little bit about some of the use cases for the data lakes. There's two kinds of use cases that have emerged for Presto, and so there's interactive, and then there's the emerging ones that I'll talk about next. On the interactive query engine side, we have reporting and dashboarding, which tends to be, as we've seen some of the stacks earlier in the presentation, with Tableau and others that you might have on top. So these are very classic SQL workloads that are running on top of the data lake. Presto is built to be a fast in-memory engine to support these use cases. SQL data science is another one where these workloads tend to be more ad hoc. So these tend to be more needed in a haystack kind of queries where you don't necessarily know exactly what you're looking for, and you're discovering. So you're discovering. You start off with a simple SQL statement, then you get it more and more complex, to a point where you find your answer, you find that needle in the haystack. These tend to be more Python driven or notebook driven, and data scientists or statisticians tend to use this approach more. And both these, reporting and dashboarding, as well as SQL data science, are very good workloads for Presto. That's what Presto was built for. The next one is federated access. Now, this use case is one that is relevant only for some of the query engines. Presto was created as a replacement for Hive, which was in the Hadoop ecosystem, and so it's primarily built for the data lake, but it also has a pluggable architecture. And because of its pluggable architecture, you can connect to many different databases along with the data lake, and actually correlate data across these databases, data sources, through a variety of connectors. That is what is federation, and federation is useful in a few different cases. In some cases, you might have data that's being generated that hasn't landed in your data lake yet. And so there might be a period of time where you don't have this data all aggregated and collected in one place. That is a good use case for federation. In some cases, you might have ephemeral data that may not ever land in the lake, and there's a period of time where it exists maybe in a cache, or like Redis, for example, and you might want to federate in some scenarios. And so that is the federated use case, which Presto supports. What we've typically seen is that the data lake use cases where you have the primary path that goes through the data lake connector for Presto, down to the cloud storage, S3, GCS, etc. Most workloads, 80% of the workloads will go through that path, and then you might have 10, 15%, 20% workloads that might take a federated approach. The next workload use case for these interactive query for Presto is customer-facing applications. Now, this is not these are not OLTP applications. In fact, OLTP applications with Presto would be a bad use case because it's not built as a relational kind of OLTP system with transactions and all of that in there. The customer-facing apps is the ones where there's analytics involved, maybe for some part of the application, and it's advanced analytics. So the customers are, again, perhaps looking for these needle in a haystack kind of queries that runs on large amounts of data, right? And so those use cases tend to be good for Presto because it's an in-memory. It has an in-memory approach, and it's very fast for even large amounts of data. So at petabyte scale, it can still run very, very fast. These are a good example of this is security use cases, cyber security use cases. So threat detection, threat hunting. Life sciences has some of these customer facing applications. And so that's another good use case for Presto. Now, there's a few emerging use cases as well for the data lake. And we'll go into this a little bit more, particularly the LakeHouse, which is starting to become, we're starting to see there's a lot more interest, I think, in the early phases of adoption. But over time, the next 3 to 5 years, the data lakehouse stack and components will become kind of the de facto stack for the data lake. So we'll talk about that. And so the lakehouse is one of the emerging use cases I mentioned. The second one that's emerging that exists for Spark quite predominantly is transformation, and this is in data lake transformation use cases. So in the past, the de facto engine was Spark, and today there are some new innovations with Presto, where Presto now supports Spark underneath it. So you can have one query engine that's Presto that actually supports two different engines underneath. It can drive Presto as well as Spark. And so these transformation use cases with ANSI SQL, they're starting to become good use cases for Presto. Let's see if there's any quick questions. All right, let's keep going. Next, let's talk about the lakehouse and what that means and what the components of a data lakehouse are. So typically in a database, right, you have a parser, a compiler, optimizer, execution engine, storage engine. You have a catalog, you have a transaction manager, you have a log manager. There's variety of different components that are tightly coupled into a database. Now, what's happened with this OpenStack and this Open Data Lakehouse is that the database itself is split apart, and a few key components have emerged. And these are independent systems that now are integrated in together that form this data lakehouse stack. The first one is the consumption on the very top. So you have dashboards or notebooks. The second component is the query engine itself. We just looked at a couple of different query engines. You can have Spark, you could have Presto, and there's a few others. This becomes the query engine, kind of is the top of the database, if you will, includes the parser, compiler, optimizer, and the execution engine, and it's the heart of the data, the heart of the lakehouse. For the query engine to get access and to know about what are the tables, right? What are the schemas? There is an operational catalog that it needs. This operational catalog increasingly there's two very popular ones. I don't think there's any others actually. The first one came out of the Hadoop ecosystem, which is the Hive Metastore, and it's very popular for on-prem use cases with both Presto, Spark, Flink, and other engines, Hive as well. And it's an operational catalog. That means that it's not a human catalog. It's different from some of the other data catalogs out there that are meant for human consumption or data analyst consumption, like Alation or Calibra, or open source variants include a Mudson, Data Hub, and others. This is an operational catalog which is basically connecting system to system, right? And so it's meant for the system, which is in this case like Presto, is the engine is hitting on the operational catalog, trying to get information about the schemas, the databases, the tables, columns, and so on. In the cloud, the most popular version is AWS Glue. Glue is compatible with Hive Metastore from an API perspective, and is very popular for S3. And this becomes a critical component of this stack, because essentially it is mapping objects in S3 or in the storage system underneath to the database elements like tables, columns, and so on. Now, up until very recently, the data lake was immutable. What does that mean? It means that storage, when you store data into S3, for example, It's immutable. You can't change it. If you have to delete it, you delete it, or if you have to update it, you insert and then you delete. So it's you can't really update data in it. And so to actually run database workloads on top, data warehouse workloads on top of the storage, you need the ability to track changes, to have logs, and so that you can then have this notion of transactions. And that's where a new component in this data lake space has emerged. They're called table formats, or in the database world would be called a transaction manager. And these are Apache Hoodie. Examples are Apache Hoodie, Delta Lake, and then Apache Iceberg is emerging as one as well. It doesn't have all the capabilities of Hoodie and Delta Lake yet, but there is a plan to get there. And so these three will be the transaction managers, or the table formats that allow for a lot more percentage of the data warehouse workloads to run on the data lake. So these 5 components together will form your data lakehouse stack. So if we go further into what that might look like realistically, this is what that stack would look like. So you have your BI tool or your notebooks on the top. Any pick any of your choice. It's bring your own. You then have a JDBC or an ODBC layer that is allows for the connectivity. Presto is the SQL query engine here, and that can either use the Hive Metastore that I mentioned earlier, or AWS Glue that you see at the bottom. And then you have this transaction manager layer on top of the data lake. These are, as I mentioned, Apache Hoodie, Delta Lake, Iceberg is coming up as well. And then AWS has a flavor of its own called Lake Formation. Lake Formation over time will become the de facto layer that sits on top of S3 for a few things. Primarily for governance, it allows for a unified governance across the lake, so that you can manage authorization and say, does Dipti have access to the customer table, right? Does Ali have access to the product table? And so that governance layer is emerging as well. Lake Formation is one option. Apache Ranger is another option that's coming out to unify security and authorization across the data lake, and that's still emerging. We'll see that get added in, but this is essentially what a data lake house stack would look like. If you're in if you're on-prem, for example, instead of S3, you would have HDFS, and you would have the Hive Metastore for sure. If you were on GCS, on Google Cloud, for example, you would have GCS as the data lake, the storage layer, and you would have a Hive Metastore. There is a new catalog that they have, a catalog service that is recently launched for on GCP as well. And that might be an option to replace Glue, for example. But still, a lot of users are using Hive Metastore for GCS. And so this stack is can be on any cloud. It's open. It's an open stack. You can run it. You can run it in on-prem. You can run it on AWS, on GCS, GCP, and other clouds, depending on whichever one you're on and where bulk of your data is. Over time, these will start to get more hybrid to allow for you to burst perhaps into the cloud if you're on-prem. And largely, there's a big migration into the cloud as well. So we are seeing this stack deployed on just purely on the cloud as well. All right, so next we'll talk about considerations for your open analytics decisions. As you start building the stack out, what are the kind of things you would like, you can think about dimensions that might help you make some of the decisions. So let's walk through these 8 areas really quick. And then we'll do a quick overview of Ahana, and then we'll open it up for questions. So the first one is data. We touched on this a little bit. Think about the kind of data formats, types of data you want to support. An open stack, an open data lake stack supports a wide range of data. So Presto, as an example, supports JSON, CSV, text, the proprietary, the columnar formats like ORC and Parquet, Avro, right? Multiple different kinds of formats. So think about what those formats are. And then from a performance perspective, think about what formats you might want to convert that data into. If performance is important, SLAs are important, then these columnar formats like or Parquet are highly recommended. If performance isn't as much of a concern, JSON tends to be more flexible, and Presto has support for nested structures and so on as well. And so that you might be able to just leave your data in that format. The next one is the type of analytics you want to run. So we talked about a range of these analytics. SQL tends to be the primary workload even today. I would say 60 to 80% of your workload might still be SQL. Python is just is a means to an end in some ways. So you might actually have Python workloads, or you might have Python to then run SQL workloads. So through these notebooks, so you might have SQL notebooks that interface the Python code and SQL code, right? And that might be a workload. And then the last one might be search. So if you have content, text, how do you want to integrate that in? Now, Presto connects with Elasticsearch, for example, or you might want to have a completely separate search analytics use case or technology or stack, depending on how search is integrated into your dashboarding or into your other use cases. Next up is the kinds of users and the personas that you as a data platform team wants to support. So typically you see analysts for sure, but you have increasingly data engineers. The data engineers tend to focus on the data pipelines, that help with cleansing, governance, transformation, for better performance, better organization, for example. So the data engineer might be one of the roles that you need to support. Think about that, how your stack would fit into that ecosystem. Analysts, we talk about scientists. And so if you're starting up a data science program, you might have data scientists that are starting to come in. They will look for easy access to some of these through SQL or for ML. And these need to be operationalized. I won't go into much detail today. That's a whole topic by itself. And then finally, the business users. So if you have dashboards and reports, all of these get seen by the business users. There might be SLAs that are required for your business users. So think about what the requirements of each of these users that you want to support are, and then how do they map to building your stack for open data lakes. The platform itself, we talked about this a little bit. So are you on cloud, or you on prem? Do you want enterprise support? Do you have enough distributed systems skills in your platform team that you can support it yourself? Or do you want support from third party that has expertise in that space? So for example, with Presto, you could use open source Presto, and Ahana as a company and as a part of the community will help you out of the community on our Presto Slack channel. However, if you're running mission critical workloads on it and you're more and more dependent on this, you might want to have a vendor and a product with a solid roadmap, enterprise grade features, tighter security, and that's where Ahana as a product and a company comes in, it offers support. So you might want to think about this for each of those components and decide on where you have skills and where you may not have enough skills in that area, where you need help from a partner and a vendor that has deep expertise in that project. On the business side, you might want to think about what those the components for the business are. We didn't touch as much on the data, the human catalog, as I call it, or the data catalog for the business side. That might be a part of your open data lake, and you might want to think about adding that in. And then finally, cost. Cost is a major factor. A big part of data lakes is they're much more affordable than data warehouses, right? And this is for many reasons. Some of them being, all your data is in one place. Storage costs are very, very low because S3 has commoditized it for everyone. And in addition to that, you don't have duplication on storage costs. You're not ingesting it into yet another system. You have one place that you're running all these different workloads on. and that makes it more cost effective. In addition, a lot of these open source technologies might be, if you just use the open source, obviously it's lower cost. Even if you use the supported versions, some of these tend to be a lot more affordable because they are a lot more cloud friendly. They have a pay go model. So with Ahana, you get you can pay per hour, and you only pay for what you use instead of a big commitment early on using that technology. So that's the cost dimension. Then finally, we have cloud. We touched on some of these earlier. Flexibility, elasticity is very important. As an example, Ahana has auto scaling. It has idle time management, which means that if a cluster is not being used for a certain period of time, it scales down automatically to one node or some minimum number of nodes, and then it scales back up once a query hits it. So elasticity might be important for you. Scale, how scalable do you want this to go? Now, data lakes and all of these technologies, Presto was created at Facebook, runs at thousands and thousands of servers, massive scale. That's what it's built for. That's the kind of scale you get with some of these uh, newer projects and newer technologies. Mobility might be an element. I'm seeing less of this today, where this is you want access on your phone, right? You want how does 5G play in it? How does IoT devices play in it? You might want to think about that. And then where do you want your data? With clouds like AWS, your data can be anywhere. S3 is highly distributed, and you have data in every single region that you might want it in. Then you get to the governance and security. So think through some of these areas on the data lake. It is quite different. And so you might have to rethink how you do governance, authorization, for example, auditing, and there's layers that are emerging on top of S3, on top of the storage, that might help you with this. For example, lake formation. Think about the business, what the business needs, value. At the end of the day, how fast can you get value for the business, right? And this is where managed services come in largely. Ahana, for example, is a managed service that makes it easy to run Presto. Presto is a distributed system, fairly complicated, but with Ahana, you can get started in 30 minutes. You can, you're up and running, connected to your data lake, very fast, and so you can see value from the analytics much faster. On top of it, there are optimizations like caching and things like that that you might want to think of to optimize speed, optimize analytics as well. And then lastly, cost. So we touched on cost a little bit, but this is just think about forecast your plans, right? Think about how scale and costs relate with each other. How are you going to charge back to your different organizations, business units? If you're supporting multiple business units, you could do it on a per cluster basis, for example. If you have a shared cluster, how would that work? And so these are some of the things that you might think of. So in general, open data lake analytics on your own, right? If you're kind of doing this on your own, can be quite complicated. Presto, for example, is fairly involved. There's thousands of configurations, and it's hard for folks who are not in the space or don't have big data experience to know what those knobs are. How do you increase task concurrency? How do you increase write throughput? Caching, right? Do you have a separate layer for caching, or is there an easier way to manage all these multiple systems? The cloud warehouses, as well as some of the serverless approaches, might get expensive. Athena, for example, is a great product if you're looking for a quick, dev and test environment to run queries on S3. But when you start looking at larger scale or for production deployments, you might hit concurrency limits. You might see issues with performance. You might see queries getting queued up. And so these are some of the challenges with open data lakes. That's where Presto and Ahana come in. I'll do a quick walkthrough of Presto next, and then a quick overview of Ahana. So Presto is a distributed query engine, as I mentioned earlier. It was created at Facebook. It's part of the Linux Foundation's Presto Foundation, and it is open sourced on GitHub. So it's all available. Welcome everyone to join the community. Uber, Twitter, Intel, HPE, all a part of this Presto Foundation. Ahana is leading the foundation. We have a lot of contributors that are helping the community. I'd encourage you to join our Slack channel for Presto as well. And this engine is a distributed engine, so it's a coordinator and worker approach. Many users for it. Some of the ones I mentioned earlier, these are some of these are large internet companies, and some of these are really small companies with one or two data platform engineers who are trying to get this open data lake stack going and innovating on it for their companies. So it's can be used quite widely across many different sizes of companies. And then Ahana. Ahana is a managed service for Presto. It's very easy to get started. You register into the application. It takes about 30 minutes to create a compute plane. So what we've done is, the way we've designed this is, we've taken the compute, which is Presto, and we've brought it to your data in your environment, in your VPC. To make this possible, we create a compute plane, which is a one-time approach, where we build an EKS cluster, Kubernetes cluster, everything from the endpoints on the top, JDBC endpoints, networking, all the way down to the operating system is automated for you using a variety of different technologies like CloudFormation templates. And once this is ready, you can create any number of Presto clusters to have access and to query on S3, to run analysis on S3. So this is a high-level architecture where you have the Ahana console, or the control plane, which is responsible for cluster orchestration, logging, security access, billing, and so on. And then the compute plane, which includes anything that touches data. So this is the Presto clusters themselves. This is superset. We bundle in superset as an admin console for Presto and for Ahana. And so anything that touches data is essentially in your VPC, in your environment, and through that you can connect to S3 and a range of other data sources as well, like RDS, Elasticsearch, and so on. And so you can bring your own BI tool. We have you can manage all of your Presto. We have a Hive Metastore that's built in, and so if you don't have a Metastore, if you don't have a catalog, it's a single click. You get a Hive Metastore that's fully managed for you, and then you can connect to a range of different data sources underneath it. So you never have to move data, right? So the data is never ingested or moved. It's in place query. There's no ETL. And that is a big advantage of Presto and Ahana. So within 30 minutes, you can be up and running, querying your S3 data in your own environment. Case study. So one of the examples of a customer that's using this approach is Securonix. Securonix is a security information and event management software. It's a SaaS product. It's a leader in the Gartner SIM Magic Quadrant, and they are using Ahana for threat hunting underneath the application. So within the stack itself is a SQL on S3 stack. It's not a LakeHouse stack, right? So it's immutable data. It's the data's landing. It's not getting updated. They pull in billions of events on a daily basis, all that gets stored in S3. And with Ahana, they saw better performance compared with the Presto that they were running on AWS, as well as much better ease of use and manageability with Ahana. And so this is the stack. They use Glue as their metastore. They have S3 as their storage engine, Ahana Presto as their query engine and their platform, and then the Securonix application, their SaaS app itself, some part of it that does the threat hunting and exposes that to their end customers, runs on top of Ahana. So in summary, Ahana is very easy to use, in another following webinar, we can do a demo of it and show that out to you. There's a lot of additional resources that we'll send out as next steps. Hope you can try that out as well. It's very easy to use, better price performance. We tune 200 plus parameters out of the box for Presto, and so you see a lot better performance. Caching is built in. You have a single click caching. You have a checkbox, and it can be enabled for every single cluster. And it's open and flexible. There is no proprietary format. We support all the open formats. It's open source. It's built on open source. We support JDBC, ODBC, the open interfaces that I talked about. And today it's built for AWS. Over time, we'll expand this to other clouds. So bring your own BI tool, catalog, transaction manager, and try it out. Give it a try. So with that, I'm wrap up the presentation. Thank you very much. Let's open it up for questions.
Okay, perfect. Thank you for that phenomenal presentation, Dipti. And attendees, please make sure to put your questions into the questions panel so we can get to them in the next 9 minutes or so. We do have a few questions already for you, Dipti. And the first one is, how does Query Presto differ from other virtualization technologies?
Sounds good. So I think the question is around Presto and virtualization. So virtualization is can mean many different things. Historically, there have been a more traditional approaches to virtualization for SQL databases. So Denodo, as an example, was a data virtualization, or is a data virtualization company that abstracted away the different databases and provided a query layer on top of the relational databases. Virtualization can also be applied to the storage layer. So for example, you can have HDFS, object stores, S3, all of these can be virtualized so that you have a unified access to all of these different systems underneath it. So if you're talking about query virtualization, then Presto is allows for federation of queries across different databases and different sources. The primary use case for Presto is the data lake. And that is basically to support querying or SQL on S3, on HDFS, GCS. But it is a pluggable, it has a pluggable architecture. And because of this architecture, it has a range of connectors that you could use for federation as well. And so that's how Presto relates with virtualization.
Okay, awesome. That was very clear. Thank you. We've got some more here for you. And this one reads, how does Ahana compare to a service like AWS Athena?
Okay, so um, in terms of different types of query engines, there's different approaches. Traditionally, you had installed services, right? So you would get a tarball or an RPM, you would install it, and that was the approach. That was the deployment model, right? With Athena, it's a serverless model, and what that means is it's kind of like a Lambda function, but for query. So um, you don't have to manage anything yourselves. You don't have to manage any servers. You just ship a query. You tell Athena what S3, where you're connected with your S3 essentially, and then you can query via Athena. So it's a serverless approach. With Ahana, it's a managed service approach. And what this means is it is a cloud managed service. So you don't have to, have hardware for it, install it yourself. It's all taken care of and automated. However, you have a lot more flexibility and visibility into what's going on in the system. With Athena, when you run a query, let's say it runs for 10 seconds, right? And there is no way for you to say, I want it to run faster, or you know what, this is too expensive, I want it to run slower. And that's the challenge with a serverless approach. It may work well for test and dev environments where you don't have heavy querying use cases. But from a HANA perspective, it's a managed service, and so you can decide how you want to add nodes. You can reduce nodes. There's auto scaling, obviously, and so you start at a certain point, and then it's scalable, and it's linearly scalable. So if you want to scale out as your amount of data increases, you can scale out, and it's a pay-as-you-go model. So it's still based on consumption. The other big difference is the pricing model. So Athena charges on a per terabyte basis per query, and so you're paying on a per query $5 per terabyte per query scan, right? And it's very hard for users to know how much data a query is going to scan, and so that may or may not work for you. Ahana charges based on compute because Presto is a compute engine, and so we charge on a per hour basis. It's 15 cents per hour as an example for an R5 extra large, and so you only pay for what you use. So those are the differences, and hopefully that answers the question.
Yeah, no, it definitely did. There's a lot of distinctions that you mentioned, so thank you. And another question for you reads, does Presto work with other clouds besides AWS?
Yes, Presto can run on any cloud. It's cloud agnostic, and so you can run it on-prem, on AWS, GCS, Azure. You can run it on any cloud.
Okay, awesome. And then it looks like our last question we have for you as of right now is, how does Presto handle security?
Okay, so broad question. There's different parts to security. There's authentication, which is typically where users start off. For Presto, it supports LDAP, for example. It supports file-based authentication, where you can create a set of users, passwords, and have multiple users authenticated into the system. And so that's kind of how it works with Presto. Authorization is the second element that's typically looked at. From authorization perspective, it supports, again, different kinds of authorizations. There's a SQL-based authorization, which is an in Presto approach. And then you can have integrations with Ranger, for example, for external authorization or external integrations when your rules or your policies are defined outside of Presto. And then finally, there's other things like encryption and so on. So Presto supports encrypted S3, as well as encryption on the wire with TLS.
Okay, awesome. And we did actually just get one last question here for you. And how is Presto different from Trino?
All right, so Presto and Trino are two different projects. Presto was the one that's created at Facebook, that runs at Facebook, that runs at Uber and Twitter, and is part of the Linux Foundation under the Presto Foundation. So it's a community-driven project. Trino is a hard fork of Presto that was forked a couple of years ago. And is slightly different. They've diverged quite a bit since that point. Presto is focused largely on data lakes, as well as some federation use cases. Trino has a larger focus on connectors and federation use cases, and is a single vendor project. So it has its own foundation. It's not a part of Linux Foundation, or it's not an Apache project. It is a project that is just a standalone foundation.
Great, thank you for that clarification. And with that, I believe we have concluded our Q&A and we're reaching time. So DZone would like to thank you, Dipti, for a great presentation.
Thanks so much, everyone. I hope you enjoyed. Take care. Bye-bye. Cheers.
Thank you. DZone would also like to thank Ahana for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day.